Right. Good evening. So in the last session, we covered few points. Let us recall those. After that, we'll start new topics. So in the last session, we covered types of the networks. We covered that we have four types of the networks: PAN, LAN, MAN, WAN. Personal area network, PAN stands for personal area network. This is used to create a network related to the individuals, like a Bluetooth connection. If you want to transfer the files from one mobile to another mobile or laptop to mobile. And PAN can be wireless and wired. Suppose if you want to take a printout from your printer with help of the cable, that type of the network is called wired personal area network, WPAN. Wireless personal area network is nothing but if you want to take the printout with help of the printer from your mobile with help of Bluetooth network. Okay, we can take the printout with help of the phone also with help of the Bluetooth network. So that is called wireless personal area network. Next level network is a LAN. This is larger than the PAN. It is used to connect the systems within a office or within a room, or within a small area. MAN is next larger than the LAN. MAN is just larger than the LAN, metropolitan area network. So as we covered just now, LAN is a network within a single room, within a single office. Okay. A MAN is collections of the rooms or connections of the offices, more than one building. Suppose if you want to maintain the network between the two buildings, then you can go for the MAN, metropolitan area network. This is larger than the local area network. Now you can see, for example, if you have four LANs, this is LAN, this is second LAN, third LAN, and fourth LAN. So to connect, or if you want to transfer the data among these four LANs, you can connect to these LANs with help of the another network. Okay, this network is called MAN, Metropolitan Area Network. So generally we use this MAN within the banks or within a city, within the city cable systems, airline reservation systems, and so on. Next larger network is WAN, Wide Area Network. A very good example for the WAN is a internet. There is no limits for that. It is used to connect the states, even countries. So this is the biggest network in all the types of the networks. See, this is the WAN. With the help of the WAN, you can connect LAN, MAN. Okay. So all over the world, you can connect any device with the help of the internet. The one more topic we covered already, types of the connections. We have two types of the connections, point-to-point connection and multi-point connection. Where point-to-point connection means a dedicated link is maintained between the two devices. The entire capacity of the link is shared between those two devices only. That type of the connection is called point-to-point connection. For example, link between CPU and monitor. So if you want to connect a CPU with monitor, a dedicated cable is maintained between CPU and monitor. The work of that cable is only transfer the data or communication between the CPU and monitor only. Next, multi-point connection. So here the same link can be shared among the multiple systems, multiple clients, multiple nodes. This type of the connection is called multi-point connection. You can see that this is the system one, this is the server. So the link which is maintained for the connections for the same cable, multiple clients are connected. So here the capacity of this cable is shared among the devices. So this is called multi-point connections. After that, we covered topologies also. Uh, the topology means arrangement of the cables. In simple terms, arrangement of the cables is called a network topology. We can arrange in different manner depending on the requirement. We may have the different arrangement of the cables. So those are nothing but types of the topologies. Bus topology, ring topology, tree topology, star mesh, and hybrid topologies. Bus topology, very simple. In this, we are using only single cable. For this single cable, all the systems are connected. So this is the architecture of bus topology. Okay. And here, the data can be in the bidirectional flow. The data can be traveled from left to right and right to left also, bidirectional. And the accessing mechanism we used in the bus topology is CSMA, and we used another technologies called CSMA-CD and CSMA-CA for the collision avoidance and collision detection. Next, we covered already ring topology. Very simple. We are connected all the devices in the ring manner. The shape is just like a ring. And to strengthen the signals, we use repeaters also. And the technology we used in the ring topology is token passing. Nothing but if any nodes wants to transfer the data, that node. So that node must maintain a token whenever. So whenever a particular node has the token, then the particular node only can send the data. This is a simple information about the token passing. Next, star topology. You can observe that all the devices are connected to the central node. That node is called hub. So all the devices connected to the central hub in the star shape. Mesh topology. Here, each and every node in the network is connected to the all other nodes in the network with a dedicated line, with a point to point to link. You can observe this image. All the devices are connected to the other devices with a dedicated link. So this is the architecture of mesh topology. And important point you need to remember, number of the links in a mesh topology of n devices, n into n minus 1 by 2, where n equals to number of the devices in that particular network topology. Tree topology, all the systems are connected in the hierarchical manner. Here we are using two types of the hubs, central hub and secondary hub. Some systems are connected to the secondary level hubs, and you maintain multiple secondary level hubs. And finally, there is a connection maintained from the secondary level hub to the central hub. So this is the structure of the tree topology. And last one is hybrid topology. By the name, you can understand that this is the combinations of any existing topology type. If you observe this image, actually, this part is a bus topology. Just now we covered, right? Bus topology. And this is a ring topology. This is a ring topology. Like that, you can connect multiple type of the existing topologies to frame hybrid topology. Now, let us discuss some more points in today's session. We recall probably all the topics we covered as of now. Then, internet, intranet, and extranet. What are these words, and what is the major difference between these words? Internet, no need to explain this because everyone knows it. Because today whatever the work you want to do, all for every work, each and every work, probably we are using smartphones. Smartphone is working with internet only. So just now we covered internet is the example of the WAN, wide area network. So here millions of the computers are connected together to transfer the data. That is nothing but internet. We can communicate and we can exchange the information with help of the systems which are connected to the internet. And the mechanism is more decentralized. The mechanism we are used in the internet is decentralized, and it doesn't have any specific owner for the internet. And it works only as a common idea that is shared by various institutions, governments, and users. Nothing but we can share the data, share the files. Those files shared by the institutions, government, and users. So this is about internet. And let me tell you one more word, that is intranet. Intranet. Here, the intranet is first point. We can implement intranet concept with help of the LAN, local area network. Just now we covered types of the networks. One of the type of the network is LAN, local area network. Now, an intranet is a local area network that has been designed for the use, this is important point, within an organization by its employees to share their information as well as work together. For example, if we have one office or organization, if the employees working within that organization wants to communicate, wants to share the information or exchange the information, they use a LAN that is called intranet, and no one can access it other than that employees, because they are maintaining some credentials, that is user ID and passwords. Like, then an intranet is also constructed from the technologies of the internet by using the protocols like TCP/IP, HTTP, and web browsers. Nothing but to implement the actual LAN, no need to use any internet related protocols and web browsers. But the internet works just like an internet, but within the organization by the employees only, within a single organization by their employees. But it works depends on the internet. This is called intranet. And the next word is extranet. This is extension for the word intranet. So just now we covered now intranet is used to exchange the information by the employees within the organization only. For example, they have one organization, college one, let us say. They want to exchange the information. In college one, they are using intranet. But let us say they have another campus, same college, they may have the uh, campus two far away from the college one or campus one. So at that time, they want to share their information, they can use extranet. Simple examples, SBI, they may have the different branches and they want to exchange the information from X location to Y location. So in such cases, they use extranet, where extranet can be used by the within the employees, point one. Second point is that can be accessed by the out of the employees also. Those employees might be suppliers or stakeholders or partners or clients. So like this is the next level of the intranet. So intranet can be used by the employees within that particular organization, but out of that organization also, out of the building also, in simple terms, other people also can access this. That person might be a suppliers or partners or clients or developers of that particular organization. And when they want to connect to this particular extranet, they must be authorized. The authorized users only can connect to this extranet. And they may be used some different type of the credentials like user ID and password. With help of that authorized stakeholders or partners or suppliers or clients might be connected to the extranet. And the primary purpose of the extranet is to extend the reach of the internal resource to the trusted external users. Nothing but Coming to the intranet, that can be used by the within that employees only. But if you want to extend this, extend the usage of the particular uh, resources to the trusted persons, trusted external persons, trusted external users, we use extranet. So with the help of this image also, we can understand the concept intranet, extranet, internet. Intranet within that organization and by the within the organization and by the employees of that particular organization and within the building only. Okay. Extranet, the persons out of that organization, but they must be belongs to that particular organization. Internet, anyone can access throughout the world. Okay. Next topic, very important topic. This is transmission media. What are the media we are using to transmit the data from one device to another device? And what are the different types of the transmission media we have? So those we are going to discuss with help of this topic, transmission media. Then before going to categorize or before going to learn different type of the transmission media, let me tell you what is transmission media first. In data communication terminology, a transmission medium is a physical path, a physical path between the sender and receiver or between the transmitter and the receiver. What is the physical communication media? What is the physical path we are using to giving the guidance to transfer the data from sender to receiver? That particular physical path is called transmission media. In simple terms, what is the channel we are using to send the data from one place to another place? That channel is called transmission media. See now, we have basically two types of the transmission media. Those are guided media, unguided media. At the top level, we have two types of the guided media. Those are two types of the transmission media. Those are guided media and unguided media. Now, coming to the guided media, again, it is divided into three types of the categories we have. Three categories we have in the guided media. Those are coaxial cables. In the guided media, we are using cables. In the guided media, we are using cables. These are different type of the cables actually. Coaxial cables, fiber optical cables, twisted pair cables. So these are the different type of the cables. And depending on their architecture, depending on their capacity, again, these cables are so subcategorized as in the coaxial cables, we have baseband and broadband. And in the twisted, we have unshielded twisted pair cables, shielded twisted pair cables. Like that, within the fiber, we have the different modes, not different cables, but we will cover that whenever reach that point. Then coming to the second side, unguided media. Here we are not using any cables. In the unguided media, we are using waves to transmit the data. And the waves we are using for unguided media are radio waves, microwaves, and infrared waves. Radio waves, microwaves, and infrared waves. So now we are going to discuss about each and every point in detail. Let us start with guided media. What is guided media? The guided media is also called wired media because we are using wires. cables to guide the data from where to where that has to be transferred. And this is also called bound transmission media, bounded transmission media. Bounded means we are deciding some boundaries. We are deciding some physical boundaries with help of the cable. Okay, the boundaries of the cable is nothing but we are deciding some boundaries with help of the cable. Through that cable only that the data has to be transferred. That's why this is also called bounded transmission media. Wired or guided or bounded transmission media. Coming to the features about the bounded transmission media or guided transmission media are high speed. Second is secure, very, very important point. Whenever we use cables, physical connection, wired connection, the connection is secured always than the wireless. And generally, this wired connection is suggestible for the shorter distance only. If the distance is very lengthy, you cannot use cables because that becomes complicated and very costly. Then, as we covered just now, in the guided media, we have the different types of the cables, right? Twisted, optical, coaxial. Let us start discussion about different types of the cables. First one is twisted pair cable. By the name, you can understand that twisting, the cables are twisted. Now, twisted pair is a physical media. Obviously, we covered that all the guided media are physical media. We are using cables, wires. Twisted pair is a physical media made up of a pair of cables. We are using here pair of cables. Those are twisted with each other. See this image. Pair of the cables are twisted with each other. Nothing but so like this, the cables are twisted to each other. That's why it is called a twisted pair cable. A twisted pair cable is cheap as compared to the other transmission media. The cost of the twisted pair cable is very less when compared to the other cables, other physical media like coaxial and fiber optics. Installation of the twisted pair cable is very easy and it is a very lightweight cable. Okay, the weight is very less weight it has. The frequency range for a twisted pair cable is from 0 to 3.5 kilohertz. That is the range, frequency range for the twisted pair cable, 0 to 3.5 kilohertz. And by this image, you can understand how the twisted pair will be. And here for these twisted pairs, there is a protection cell with the plastic that is called a jacket. Okay, this is for the protection to give the protection for the twisted pair cables. And a twisted pair consists of two insulated copper wires, one, two, two insulated copper wires arranged in a regular spiral pattern. You can observe this twisted to each other, or in simple words, this is just like a spiral pattern it has. And next point is in the twisted pair, again, we have two categories. Two types of the twisted pair cables we have. Those are unshielded twisted pair, shielded twisted pair. Okay, shielding, depending on the protection, we have two types. Those are shielded and unshielded. See, unshielded twisted pair cable. By the name, you may understand that unshielded, there is no proper protection. Shield means protection, dictionary meaning, right? No. It is the most common type of the telecommunication which consist of two conductors. Usually those are made with copper, each with its own plastic color. Okay, every the one is maintained its own color. So why they are maintaining the color is for the identification purpose. And UTP nothing but unshielded twisted pair cable. The short form for the unshielded twisted pair cable is UTP. UTP cables consist of two or four pairs of twisted cables. Two or four pairs. Now see, so these are unshielded twisted pair cables. As we covered, we have four twisted pair cables here. Okay, four twisted pairs. Now, let me tell you some more important points. We have the different categories in UTP also, depending on the speed only. Depending on the speed, it have different types of the or different categories of the unshielded twisted pair cables. Let me tell you the names of those. Category 1. Category 1 UTP. Category 1 unshielded twisted pair cable. So here UTP category 1 is used for the telephone lines. Okay, a land phone. For the land phones, they use this type of the cables. And it has low speed data. The data transferation speed is very low. Then category 2 UTP, it supports up to the 4 Mbps speed. Okay, it has good speed than the category 1. Category 3, it is a greater speed when compared to the category 2 into uh, into 4 times. Okay, 4, but here that is 16. The capacity of the category 3 is up to 16 Mbps. Then in category 4 UTP, it supports up to 20 Mbps. Okay, and therefore it can be used for the long distance communication. If you want to do any communication for the long distances, you can use category 4, that is best suitable for this purpose. Then category 5, it supports up to 200 Mbps. Very huge capacity it has, 200 Mbps. Then coming to the advantages, it is cheap and installation of UTP is very easy. As we covered, it can be used for high speed LAN also. And disadvantages, this cable can only be used for the shorter distances because of attenuation. Of course, it can be used for the as we covered for the long distance, but it is not suggestible because if we use this, we may face the problem of attenuation. Then what is attenuation? Attenuation refers to the gradual loss of intensity of the signals. We may lose the signal intensity gradually. That problem is called attenuation in the networking terminology. So as of now, we covered about UTP, unshielded twisted pair cable. Now, second category in that twisted pair is shielded twisted pair cable. If you observe this, there is a shield cover. There is a shield. Observe this in the silver color. Okay. There is a shield here. That's why it is called shielded twisted pair cable. If you observe this, there is no shield for the pair. For this pair, we don't have any shield. Okay. But here we have a shield for each and every pair. That's why the name is shielded twisted pair cable. Now, this type of the cable consists of a special jacket to block external interference. This one. This shield is used to reduce external interference for the cables, twisted pairs. And it is used for the fast data rate, Ethernet, and invoice and data channels of the telephone lines. And whenever if you want to transfer the data in the fast rate, like Ethernet means LAN-based internet connection that has a greater speed. So in such cases, you can use shielded twisted pair cables. Let me tell you some characteristics of the shielded twisted pair cables. The cost of shielded twisted pair cable is not very high and not very low, moderate cost it has. The installation is easy and it has higher capacity as we compared, and it is higher capacity to the compared to the unshielded twisted pair cable. It is shielded that provides the higher data transmission rate. And the disadvantages is it is more expensive as compared to UTP because it maintaining some type of the shielding. That's why it is a bit expensive than compared to the unshielded. Next. See this? So as of now, what we covered, twisted pair cables, and in the twisted pair cables, we have two categories, unshielded, shielded. That is what we covered. Then, and in the category of the cables, we have twisted pair, coaxial, and fiber optic. Second category is coaxial. So this is a basic architecture of the coaxial cable. Here we have inner conductor. This is the inner conductor. This is the main thing to connect the cables. And we have the insulators. And we have one outer conductor also, inner conductor. And we have one more outer conductor. For this, for the protection, it maintains one plastic cover. Generally, if you observe this type of the coaxial cable in the uh, TV connections, dish TV connections. Okay, if you have any cable TV connections for the televisions, you can observe that generally it is in the black color. That cable is coaxial cable. So coaxial cable is very commonly used transmission media in TV wire. The name of the cable is coaxial as it contains two conductors parallel to each other, coaxial, because the two maintaining same axial. It has higher frequency as compared to the twisted pair cable. And in the twisted pair, we have UTP and a shielded twisted pair, unshielded twisted pair. Na? Like that. In the coaxial cables also, again, we have two types. Those are broadband and baseband. First one is baseband. This is 50 ohm coaxial cable, which is used for the digital transmission, digital data transmission. Mostly, it is used in the local area networks. And baseband transmits a single signal at a time with very high speed. It is used to transmit single signal at a time, but with very great high speed. The major drawback in this baseband is it needs amplification after every 1,000 feet distance. After every 1,000 feet distance, it need amplification. Amplification means we need to regenerate the signal of that particular source because it is going to reducing the strength of the signals. If you use amplifiers, the amplifier can amplify the signal strength. A second category is broadband, and this uses for analog transmission. The major difference between a baseband and broadband, observe here. The broadband uses for the analog transmission, where baseband used for the digital transmission. major difference. It transmits several simultaneous signals using different frequencies. But in the baseband, what we covered, that is used to transfer only single signal at a time. But here, it is used to transmit several signals simultaneously. Then, broadband covers large area when compared with baseband coaxial cable. The baseband coaxial cable is suggestible to cover a small area only, but it is used to cover large area, broadband. Advantages of coaxial cable. The data can be transmitted at high speed and it has better shielding as compared to the twisted pair cables because there is no strong protection for the twisted pair cables, but the coaxial cable is very strong. Then it provides higher bandwidth. Next, disadvantages of coaxial cable is it is more expensive as compared to the twisted pair cable. Third category of the cables, fiber optical cables. The method of the fiber optical cables to transfer the data is very different compared to the existing tools, coaxial and twisted cable. See that? It uses the concept of reflection of light. This is very important point. The fiber optical cables uses the concept of reflection of light through a core made of a glass or plastic. Through a glass, they use reflection of the light concept to transmit the data. The core is surrounded by less dense glass or plastic covering that is called cladding. See this? This is the core and we have this cladding part. As we covered, the core is surrounded by a less dense glass that is cladding. You can observe this is a cladding. Okay. Then this is used to transmit the data. For the large volumes of the data also you can transmit with the help of the fiber optical cables. And the cable can be unidirectional or bidirectional. Okay, we have two types of the fiber optical cables. Some fiber optical cables are unidirectional. They are used to transmit the data in one direction only. And we have bidirectional fiber optical cables also. Now, see this outer jacket for the protection purpose again. Okay. Then we cover this now core. The optical fiber consists of a narrow strand of glass or plastic that is known as core. This one. Okay. That might not be, that might not have good visibility because that is also in the white color. Background is also white color. A core is a light transmission area of the fiber. This is the actual part where the light can be transferred. The more the area of the core, the more light will be transmitted into the fiber. Okay. The more the area we have, then the more light can be transmitted about this core. Next. So this is about core. Cladding. The concentric layer of the glass is known as cladding. This one. The main functionality of the cladding is to provide lower refractive index at the core interface as to cause the reflection with the core so that the light waves are transmitted through the fiber only. That is the concept of cladding. Jacket, very simple. It preserves the fiber strength. And the main purpose of the jacket is to observe the shock also. Okay. As simple terms, it is used to give the protection. Then we have different type of the modes and different methods. Different of the modes for the propagation of the fiber optic cables. Those modes are single mode and multi-mode. Multi-mode, single mode. And within the multi-mode, again we have step indexed multi-mode, graded indexed multi-mode. This is the mode structure. Then what is mode? The way of transmitting the data from source to destination. That is the mode. How the light is propagated. Based on that, we have these categories. So coming to the multi-mode and single mode, the propagating light along optical channels, each requiring fiber with the different physical characteristics. So this is multi-mode step index, multi-mode graded index. And this is a single one. Observe this, single channel, single direction, straight direction. This is about single mode. And coming to the multi-mode, see now, step index. This is like a steps, one step, second step, third step, and so on. And here we have multiple transmission routes. And this is graded index, not just like a step, it is just like a wave. Okay, the mode is different. Next, it has a greater bandwidth and it has good speed. It is used for the longer distances. It has a better reliability also. The fiber optic cable is more reliable than the copper cable as it is immune to any temperature changes. This is very important point. Okay. Depending on the temperature also, the temperature also affect the data transmission rate and speed. But coming to the fiber optical cables, it doesn't affect with temperature changes. So this is about guided media. As of now, we covered about the guided media only. Guided media, in that we have three cables, twisted pair, coaxial, and fiber optic. In the twisted pair, we have U2P, that is unshielded, twisted pair cable, twisted pair cable. And coming to the fiber optic, we have the different modes, single mode, multi-mode. That is we covered as of now. Now, second category in the top level is unguided media. By the name, you can understand that unguided, there is no guidance. Simple, right? Unguided means there is no guidance. Because when we use the word guidance means we are giving the guidance to transmit the data with help of the cable. But if you are not using any cable, there is no proper guidance. So that is the meaning of the word unguided here. Unguided media, it is also referred as wireless or unbounded transmission media because we are not using any wires, any cables. That's why it is also called wireless media. And there is no bounds are decided. If you are using any cables, we can decide the boundary of the cables. But here there is no cable we are using. That's why it is also called unbounded transmission media. As we covered just now, there is no physical media is used in this unguided transmission media. We use only electromagnetic signals. This is important part. In the unguided media, we are using electromagnetic signals to transmit the data. But coming to the features of the unguided media, the signal is broadcasted through air. Very important feature in unguided media. The signal is broadcasted through air and it is less secured. As I covered just now, whenever if you use cables in any network, in any concept, the cable network is more secure than the wireless network. Wired network is more secure. This is a common rule. As unguided media is a wireless media, it is less secure compared to the wired. Used for very large distances, this is very good advantage of the wireless one because no need to maintain the cables. So even though it is very difficult to maintain the cables in some places, we can use directly unguided media there. For example, Geo Air Fiber. In some areas, there might not be maintenance of the Geo cables, Geo Internet cables. In such cases, directly you can use Geo Air Fiber. No wires are needed. That is one of the example for the unguided media, wireless connections. Unguided signals can travel from the source to destination in several ways. Ground propagation. This is about ground propagation and below 2 megahertz and sky propagation and line of sight propagation. You can observe this. This is bidirectional in the ionosphere, and this is sky propagation. This is the direction they follow in the sky propagation, and antenna to antenna, that is line of sight propagation. Ground propagation in this, radio waves travel through the lowest portion of the atmosphere. You can observe here. So this is what the dotted lines. Okay. So here the waves travels to the lowest portion of the atmosphere, hugging the earth. So these low frequency signals emanate in all directions from the transmitting antenna and the follow curvature of the planet. See, in the all directions, the waves are going to be used. Sky propagation in this higher frequency, higher frequency. Higher frequency radio waves radiate upward into the ionosphere. If you observe this image, upward to the ionosphere, right? Where they are reflected back to the earth. Now see, that is reflected back to the earth in the sky propagation. This type of the transmission allows for greater distance with the lower output power. If you want to cover very greater distance, then you can go for this method, sky propagation. Next one is line of sight propagation. In this type, very high frequency signals are transmitted. Low, high, very high. Transmitted in the straight lines directly from antenna to antenna. Now you can say the straight line manner from one antenna to another antenna. Now, there are three types of the signals transmitted to the unguided media, different type of the waves, simple. Radio waves. These are easy to generate and can penetrate through buildings. And frequency range of radio waves, 3 kilohertz to 1 gigahertz. Sending and receiving antennas need not be aligned. To send and receive, the antennas need not to be aligned. FM radio and AM radios and cordless phones uses radio waves for the transmission of the data. And these radio waves furtherly categorized as terrestrial and satellite. So this is a brief information about the radio waves. See this? Electromagnetic waves ranging in frequency between 3 kilohertz to 1 gigahertz are normally called radio waves. Radio waves are omnidirectional, and when the antenna transmits radio waves, they are propagated in all directions. This means that the sending and receiving antennas no need to be aligned. The data is being transmitted in all directions. Then second type of the waves is microwaves. Electromagnetic waves having frequencies between 1 gigahertz to 300 gigahertz. Electromagnetic waves having frequencies between 1 to 300 gigahertz are called microwaves. And microwaves are unidirectional, where radio waves are omnidirectional, right? Just now we covered the point. Radio waves are omnidirectional, but microwaves are unidirectional. When an antennas transmit microwaves, they can be narrowly focused. This means the sending and receiving antennas need to be aligned. This is the major difference between radio waves and microwaves. If you are using radio waves, no need to be aligned the antennas. But here microwaves, the antennas must be aligned. Next type of the waves, infrared waves. Infrared waves are used for very short distance communication and they cannot penetrate through the obstacles. Nothing but if you used any object while any infrared waves are transmitting, if you are using any object in that way, that will be stopped there. Okay, that cannot be penetrated through the obstacles. Frequency range is 300 gigahertz to 400 terahertz. Then it is used in TV remote, wireless mouse, wireless keyboard, and printer. Suppose if you want to change the channel in your TV, you can use TV remote. Generally, the waves used while you are using TV remote is infrared, infrared waves. The connection is maintained with the help of the infrared rays with your TV remote to your TV. Suppose if you are using any obstacle in between remote and TV, then that might not be work properly. Okay, this is about infrared waves. So we will start new topic in a tomorrow session. Before that, let me recall in brief what I covered in today's session. So we started our discussion with internet, intranet, and extranet. Internet is nothing but a network which doesn't have any limits, and no one is owner for that. The major idea of the internet is to exchange the data. And coming to the intranet, for example, within the organization, the employees of the organization wants to exchange their data. They can use intranet. Internet is also implemented based on the LAN technologies and they use internet related protocols like TCP/IP and they use web browser also. Then extranet, this is the enhanced version of the intranet. If you want to enhance the features of the intranet, then we can go for the extranet. For example, any stakeholders or clients or any other higher authorities wants to access any organization data from the outside of the data, from the outside of the organization, they can access that particular organization's data with help of the extranet. But the users might be authorized users. With help of some credentials, they can access that. So this is a brief information about internet, intranet, and extranet. Now, after that, we started the concept of transmission media. The word transmission media, nothing but what is the channels we are using to transmit the data from one place to another place. That is called transmission media. And at the top level, we have two categories. Those are guided media and unguided media. When we use the word guided means there is a guidance, nothing but that is physical existence is there in the form of the cable. That is the meaning of guidance. And you can call it as guided media. You can also call it with the name wired or bounded, unguided media, wireless media, unbounded media. There is no bounds. And bounds means physical bonds. If you use cable, there is a physical bonds. And in the guided media, we use three different type of the cables. Those are coaxial cable, fiber optical cable, and a twisted pair cable. So in the coaxial, again, we have baseband and broadband. Fiber optic cables works based on the light capacity, and we have the different modes in the fiber optic, single mode and multi-mode. Twisted pair cable, you can observe the cables are twisted together. And within twisted also, we have two categories. Those are unshielded, shielded. In the shielded, a separate shield is maintained in the form of the protection with a silver color, what we observed in the image. Those are shielded. Unshielded means there is no particular shield is maintained to reduce the external interference from the one twisted cable to another twisted pairs. And coming to the unguided media, here we are not using any cables. There is no physical existence for the guided media. We are using waves, and we use three different type of the waves: radio waves, microwaves, infrared waves in the unguided media or unbounded media or wireless media. Radio waves, radio waves are omnidirectional, and the antennas no need to be aligned to use radio waves because these are omnidirectional. And microwaves, these are unidirectional only. The antennas must be aligned. And infrared, these are used for the short range areas like a TV remote. If you want to operate TV with help of the TV remote, the TV remote is going to connect to your television with help of the infrared waves only. If you have any obstacle, any object between these infrared waves and TV, that infrared networks may not be work. So this is what we covered in this session. In the next, we will going to discuss some more important points like what are the different type of the uh, connectors we use while working with the networks. Network connectors. The topic name is network connectors. We have different type of the connectors like RJ45, RJ11, and RJ12, CAT cables. And we have different type of the CAT cables again. HDMI cable and different types of the HDMI cables, OTG connectors. Okay. So with that topic, we can close block 1, that is unit 1, unit 2, unit 3. After that, after completion of this topic in the tomorrow session, if time permits, we will start block 2 also. Okay. So that's it about today's session.